So here is a question from a member of the group. The question says to calculate the exact, so the term exact there is important. Calculate the area, the exact area of the red rectangle that is shown there. Okay, all the measurements there are in centimeters. Okay, so I will not put centimeters just to save some space. Okay, so we want to find the area of the red triangle. So let's see how we go about this particular problem. Okay, so the first thing I'm going to do is to just rearrange place the question, the diagram as it was stated in the question. So we have a triangle there. It's a right angle triangle of side A, B, and C as shown. Side AB, I think, was 8 centimeters. Side BC down there was 6 centimeters. And angle B there has been bisected by line, I'll call that line BM. So M does not appear in the diagram given by the student. Okay, but I've decided to call that M so that it makes our references easier. Okay. Okay, and so angle B there is divided into two equal parts. Let's call those two equal parts theta. Okay, now here is the important part that a student may not realize. So if these two angles are equal, and suppose we say that the side MC or CM, if you like, let that side be of length X, then if I draw a right angle triangle here with the right angle at this point like that, if I do that to create angle N there, that angle there being right angle, then this length MN must be equal to length MC. In other words, that length must also be X. Okay? That is what is important in this question. And as soon as we have that, we have come up with two similar triangles. So we are saying that angle there has to be 2 theta. That is to say it must be equal to this angle here. All right. And therefore, we can assume, because these two triangles, the red triangle and our triangle ABC, must now be similar triangles. Okay, so we know that because these two angles are equal, and so if this is 90 degrees here, then if I join a perpendicular to line AB, that angle being 90 degrees will ensure that this triangle MNB must be the same as triangle MCB. And because of that, that triangle there must be similar to the large triangle ABC. That is the trick about this question. Now, if these two triangles are similar, I'm going to arrange it in the next slide. If these two triangles are similar, then which sides are corresponding to one another? So we are saying this is a case of similarity. So we are saying triangle ABC has to be similar to triangle AMN. Okay? If they are similar, then clearly angle B there must be corresponding to angle AMN. That angle there must be 2 theta. And the angle that is the right angle there, N there, must correspond to C, and angle A has to correspond to itself, because that's the same angle for the small triangle. It's also the same angle for the larger triangle. Okay, so for that reason, these two triangles are said to be similar. Okay, I'm just going to rearrange this so that it faces the same orientation as the larger triangle. So we are saying side AC there. Okay, first of all, let's find the value, because we know this is 8 and this is 6. Let's find the length of AC. So clearly AC by Pythagoras theorem has to be 8 squared, the square root of 8 squared minus 6 squared, right? So the square root of 8 squared minus 6 squared, 8 squared is 64, 6 squared is 36. So the difference there, I think, is 28. So this is the square root of 28. 28 is 4 times 7. I'm trying to reduce that into a smaller irrational number. So 28 is 4. 4 is a perfect square. 4 times 7. And so I can write this as 2 root 7. Okay, it's not important, it's not a must, but it makes calculations easier later when we have smaller radicals. Okay, and so this is the same as 2 root 7. Okay, now we are saying the two triangles are similar, so we can look at the corresponding sides. All right, so side AB there, if you look at side AB, so that is 2 root 7, or if you like, you can write the square root of 28. So the side AB, which is the hypotenuse of the larger triangle, must correspond to the side AM, which is the hypotenuse of the red triangle. Okay, so AB corresponds to AM. So the the two-sided arrow there indicates that the two sides correspond to one another. Okay. Similarly, the side BC, which is the base of the larger triangle, must correspond to the side NM, or MN if you like. This is the base of the small triangle. So side BC, I think let's start with AC, which is the height of the larger triangle. So the height of the larger triangle must correspond to the height of the red triangle, which is AN. So AC on the large triangle must correspond to AN on the red triangle, the smaller red triangle. And finally, the base BC on the large triangle must correspond to the base of the largest length, the bigger of the smaller sides of the triangle, that is MN there, must be corresponding to one another. So BC corresponds to MN. This is important information, because we are going to use the idea of similarity, and we need to know which sides correspond to one another. Okay? All right, let's move on. So now I'm going to rearrange this diagram so that you can see more clearly the correspondence. I didn't have to do that from here, but just to make it look more clear to some students, let's rearrange this. So I can put this so that the base nicely is parallel to the base there, and the height there is nicely parallel to this height, and the hypotenuse also parallel to one another, like that. So I've rearranged it, keeping my information there the same. Okay, so if these two triangles are similar, then what we know is that the ratio of the corresponding sides must be equal. So which is to say, if I take AM and divide by AB, which are the two corresponding sides, I've placed them in such a way that the corresponding sides are also parallel. So if I take that and divide by this, what I get is the same as taking the base there and dividing by the base here, and is also the same as taking the height here and dividing by the height there. So the ratio of the corresponding sides must be equal. Okay, so let's see what we mean by this. So we are saying if this side, so this is x as we had seen in the previous diagram, so this is going to be x, and I will refer to that as height. Okay, so let me just go back slightly. So looking at this diagram here, we can see that if the distance AC is 2 root 7 as we had calculated earlier, and MC is x, then it means AM must be, so we can write, therefore, AM here must be 2 root 7. This must be 2 root of 7 minus x. This must be this distance here. Okay, keep that in mind, so that on the other side, the hypotenuse of the smaller triangle, the red triangle, is going to be 2 root 7 minus x. Okay? And so if this is x, but the hypotenuse there is going to be 2 root 7 minus x, as we have just determined. And we shall let this side be h, like that, the height of the smaller triangle. The question is to calculate the area of that red triangle, and to do so, we need the height and we need the base. Okay? So now let's go into the idea of similarity. So from similarity, we know that the ratios, if I take AM, which is the hypotenuse there, divide by the hypotenuse here, whatever I get must be the same as the ratio of the next corresponding sides. So another corresponding side would be MN, which is the base there, divide by the base there. Okay? Substituting for these values, AM is 2 root 7 minus x, that's AM, so I'm going to put that there. Okay, I will replace that there. and AB is 8, so 2 root 7 minus x over 8 must be equal to mn, which is the base there, x divided by 6. I hope that is clear. To make x the subject, I'm interested in finding the value of x. So to make x the subject of the formula, we just cross multiply. So 8x must be equal to, so 6 times 2 root 7 is 12 root 7. 6 times x is 6x. So 8x must be equal to 12 root 7 minus 6x, like this. So 8x there must be 12 root 7 minus 6x, and I can take the 6 minus 6x to the other side. I end up with, if I take minus 6x to the other side, I end up with 14x. So then I can write here that 14x must be equal to 12 root of 7. And clearly we can see that x, I can write this value of x here. So then x must be equal to 12 root of 7 divided by 14, like that. Okay, of course we can simplify that, and that is 6 root 7 divided by 7. All right, so the value of x is 6 root 7 divided by 7. We still need to find the height of that smaller triangle. Okay, let's see how we get that. And so according to what we have found there, the length x, or the base of that red triangle, has to be equal to 6 root 7 over 7. Okay, so we're going to work with that figure. Let's just move to find the value of h. Again, we are using the same kind of reasoning. So we know the value of x is now 6 root 7 over 7. Now let's try and find the value of h. Once again, we need to be looking at the two similar triangles. And if we do that, there we go. We can find h by again comparing corresponding sides. So the side h corresponds to the side AC there, which is 2 root 7. And we can compare with the side that we've already used. So that is side mn, which is 6 root 7 over 7, and we would divide that by the corresponding side there, that is 6. Okay, so we can say then that the side an corresponds to the side AC. So an divided by AC, an divided by AC must be equal to mn divide by BC. Okay, like that. And so if we substitute the values, h over 2 root 7 must be equal to that. If we simplify that slightly, we can see that that is 6 root 7 over 42. Please just do that your own way using your understanding of fractions. This is what you'd refer to as a complex fraction, but not really that complex. So it is 6 root 7 over 42, there, like that. And if you rearrange that, maybe I should do this here. So this bit here is equal to 6 root 7 over 42. Okay, now h then, therefore h equals of 42. I can multiply 42 with h, or take that and multiply there. And so I have 6 root of 7 multiplied by 2 root of 7, and everything divided by 42 there gives me, this is 12 times 7, which is 84. 84 divided by 42 gives me h equals 2. So I know the value of h then is equal to 2, right? And so simplifying this complex part, we end up with, as we said, 6 root 7 over 42. And when we simplify that, we get that h is equal to 2. Because of that, we can now go ahead and replace that x there, that h there, with 2. Okay, and that leaves us with both sides of the red triangle now known. All we have to do now is find the area. And you would know, of course, that the area of a triangle is a half times base times height, or base times height divided by 2. And all we have to do is now substitute in. If we do so, we get a half. Our base is 6 root 7 over 7, and multiply that by 2. The 2 can cancel the 2 on the other side, and so we are left with an area of 6 root 7 over 7. Now the question says to leave our answer as exact, and that means we leave it like that, right? If you try to change that into a decimal, then it means the answer you get. Now, root 7 is an irrational number, meaning that when you change it into a decimal, it has non-ending, non-recurring decimals, and therefore all you can do is approximate the answer. So if we want an exact result, we must leave it as it is. Okay? I'm hoping that this made sense. Please like the video if it was useful, and consider also subscribing to the channel. You can do so by scanning directly onto that QR code, or going to ELIMIKA DUNIA, or going to YouTube and typing in ELIMIKA DUNIA. You should be able to see our videos there clearly. There will be full classes in case you missed a lesson at your school. You can always go in and check some of the videos. There are complete classes. Hoping you enjoy that. All right, keep the questions coming. I'll see you in the next one.